In this presentation, we're going to look at how to write a hypothesis, which is a really common question in A-level psychology. You'll often be given a STEM and asked to write an appropriate hypothesis for that situation or piece of research. So, every experiment has an alternative, or otherwise known as an experimental hypothesis, which is basically the statement that you wish to test. It's a prediction, it's what's expected to happen. There's also always a null hypothesis, which simply states that the results were due to chance and not the manipulation of the independent variable. The null hypothesis makes more sense when you come on to statistical significance and you're looking at 95% confidence levels, that you want to be 95% confident that your result was due to the manipulation of your independent variable and not due to chance. Within every hypothesis, there will be an independent variable, the cause, which is the variable that's changed or manipulated by the psychologist. And of course, there'll also be a dependent variable, the DV, the effect, and that's what changes as a result of the manipulation of the IV. IVs and DVs must be fully operationalised in a hypothesis, and all this means is that they're stated in a clearly measurable form. Let's look at an example. If we had a really simple idea of time of day will affect memory, that's not really a hypothesis because the variables have not been operationalised. It's more of a statement really, or an aim. So we need to operationalise the IV. In this case, the IV is the time of day. Normally you have two conditions of your IV, so we might operationalise time of day as morning 9 AM and afternoon 3 PM. How are we going to operationalise memory, our DV, what we're measuring? A simple way would be number of words recalled from a list of 20 common words. So we've now got our operationalised IV and a DV, and we can put those into a hypothesis. So our alternative hypothesis here would be there will be a significant difference. The word significance is important because we use significance testing later on when we do our stats. So there will be a significant difference in recall of a list of 20 common words between participants who complete the task in the morning, 9 AM, and those that complete the task in the afternoon, 3 PM. And here we've used a non-directional hypothesis, but more about that later. Our null hypothesis, there'll be no significant difference in the recall of a list of 20 common words between participants who complete the task in the morning, 9 AM, and those that complete the task in the afternoon, 3 PM. Any difference is due to chance. We need to know whether our hypothesis is directional or non-directional. They're also referred to as one-tailed for directional and two-tailed for non-directional. If you think about it, directional is predicting the direction of change, so it can only go one way. Non-directional is just saying there will be a change, so it could go either way. So a directional one will use words like faster, slower, bigger, smaller, more, less, etc. So an example, alcohol increases reaction time. You've been precise, you've said exactly what change you're expecting. A non-directional or two-tailed hypothesis doesn't specify direction, so it's used when there's no previous research and it's non-specific. It uses words like affect, change, difference. So alcohol will affect reaction times. Remember that point though, you use a non-directional if there's been no previous research. If there's been previous research, then you can use a directional hypothesis. When you're presented with a STEM in an exam, there are 4 things you need to ask yourself. First of all, is the hypothesis going to be directional or non-directional? And what you're looking for in the STEM is any mention of previous research. If there's a mention of previous research, then you can write a directional hypothesis. If there's no mention of previous research, then it's got to be non-directional. The second thing you need to ask yourself is the research looking for a difference or a correlation? Because obviously that will affect how you write your hypotheses. What's being measured? So what's the DV? And crucially, how is the DV operationalised? How is it being measured? And what are the two groups of the IV, and how is the IV being operationalised? So let's have a look at an example from an exam paper. So the STEM says, it was recently reported in a newspaper that time spent playing team sports increases happiness levels. A researcher was keen to find out whether this was due to participating in a team activity or due to participating in physical activity, as he could find no published research on this. Now that bit about no published research is telling us it's going to be non-directional. Don't be confused by the report in a newspaper. A report in a newspaper is not published psychological research. Participants in Group A were requested to carry out 3 hours of team sport per week, and participants in Group B were requested to carry out 3 hours of exercise independently in a gym each week. So that's our IV. So 3 hours of team sport per week and 3 hours of independent exercise in a gym. So we've got our two conditions of the IV there. All the participants completed a happiness questionnaire at the start and the end of the study. The researcher then calculated the improvement in happiness score for each participant. So our DV is the improvement in happiness score. It's not the score on the happiness questionnaire, because remember they're doing it twice. What we're measuring is the difference. And the question would be, write a suitable hypothesis for this experiment for 3 marks. So here's an answer that would get 3 out of 3. There will be a significant difference in the improvement in happiness score measured by questionnaire between the group who carry out 3 hours of team sports per week and the group who carry out 3 hours of independent exercise at the gym. Note the IV and the DV are fully operationalised and a non-directional hypothesis has been used. There will be a significant difference. It's not saying which group will have a higher improvement in happiness score. It's just saying there'll be a difference. If you'd written that and made it directional, you'd get no marks, because one of the things that you're being examined on is whether you understand that you've got to write a non-directional hypothesis because there's no previous research. So let's have a go at another example. A researcher is comparing the time taken to complete a lap of a driving obstacle course of male and female participants. The researcher found a paper which suggested that males tended to drive faster than females. So our first question, is the hypothesis directional or non-directional? Has there been previous research? Well, in this case, yes, the researcher found a paper which suggested that males tended to drive faster than females, so we can write a directional hypothesis. Our next question, is it looking for a difference or a correlation? Well, it's comparing the speeds of male and female participants, so it's looking for a difference. What's being measured? Well, what is being measured is the speed taken to complete a lap, or time taken to complete a lap of a driving obstacle course. And I suppose we could argue that that would be measured in seconds. So time taken to complete a lap of a driving obstacle course in seconds. And finally, what are the two groups, the IV, and how is it operationalised? Well, this one's really simple because the IV is gender and it's operationalised by males and females. So now we've got that information, we can write our hypothesis. So our alternative hypotheses, males will complete the driving obstacle course in a significantly quicker time, seconds, than females. Nice and simple. Our null hypotheses, there will be no significant difference in the time taken to complete a driving obstacle course measured in seconds between males and females. Any difference is due to chance. I hope this presentation has helped you understand how to write hypotheses. As always, please read the section in your textbook and look at past paper questions so that you can practice writing hypotheses. This is an easy 3 or 4 marks if you've practiced it. All the information that you'll need to write your hypotheses is always given to you in the STEM, so there's no excuse for not getting 3 out of 3. Thank you for listening.